Welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see about the continuity of the previous topic, rooting characteristics and how the plant gets water from soil. That comes under the unit soil water tension and measurement of soil water, that comes under the subject irrigation and drainage engineering for the students of third year 6th semester. At the previous class, we have seen about what is irrigation and what happens when there is an application of water and what comes under supplemental irrigation. Also, we have seen an example what needs to be maintained in order to provide a crop yield with a quality crop. So, in order to maintain those kinds of things, we have to specifically see what is necessary and what are the requirements and how those kinds of requirements could be meted out. Today, we'll see how the plant gets water from soil. We do know that the water is essential for the plant growth, and also we do know that without the enough water normal plant functions are disturbed and the plant gradually wilts, stop growing, and it obviously gets died. The plants that are most susceptible to damage from the water deficiency during the vegetative and reproductive stages of growth, or also we can say that many plants are very sensitive to the salinity during germination and general growth stages. Most of the water that enters a plant root does not stay in the plant, and also less than 1% of the water will get withdrawn by the plant actually is used in photosynthesis. Here, I have to say you that the rest of the water moves to the leaf surfaces where it transpires to the atmosphere, and the rate at which the plant takes up water is controlled by its physical characteristics, atmosphere and soil environment. The rate at which the plant takes up water is controlled by its physical characteristics. That means that the atmosphere, soil environment and the physical characteristics are interrelated to each other, and so that the water that has been absorbed by the plant will be in a very controlled nature. As the water moves from the soil into the root, and after which it gets into the stem and then it gets into the leaves, through the leaf stomata to the air, it moves from a low water tension to a high water tension. This water tension of the air is determined in large parts by the relative humidity and always is greater than the water tension in the soil. So this is the picture that you guys have to know how the plant gets water from oil. This picture illustrates the energy differentials that drive the water movement from the soil into the root, up to the stalk, into the leaves and out into the atmosphere. The water moves from a less negative soil moisture tension to a more negative tension in the atmosphere, and during the course of a growing season, plants will extract about 40% of their water from the top quarter and 30% from the second quarter and 20% from the third quarter and also 10% from the bottom quarter of the root zone. As you see here, everything has been intimated in a negative soil moisture tension. So each and every root capability has a certain amount of capacity to absorb soil water. So here, as you guys can see that first quarter, that is topmost quarter, that is initially below the surface, will have a capability to absorb 40% of their water, and the remaining 60 percentage will be split up into 30, 20 and 10%. 30% of the second quarter will be absorbed by the second staff, and the 20% will be from the third quarter, and the bottommost root zone is capable of absorbing only 10%. So that means here you guys have to split them up into four quarters. Here one, here one, here one, and this one. So that means you are splitting up the into four quarters, and the lowermost quarter is only capable of absorbing 10 percentage, and the third quarter is capable of absorbing 20 percentage, and the third one above the root zone is capable of absorbing 30 percentage, and the topmost is capable of absorbing 40 percentage of their water from the top water. Okay, so this is how the plant will extract them. So here I have shown you a physical nature how the soil is capable of extracting those kinds of water, and these kinds of water has to be converted from the root zone to the stem, from the stem to the leaves, and then to the atmosphere. So the movement of the water is always from downwards to topmost. So that is where why we are intimating that soil water passes through negative soil moisture tension. So this is how they interact. At the next class, we'll see about how the soil and water gets interacted, and what is the most important thing that has to be known by us, and how this is directly imparting the effects on the strength of plant growth, and also the crop yield gets impacted due to the soil moisture tension. Okay, if you guys have any kinds of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.